Section 1.4 is titled Multiplying Integers. So our standard here is 7C3, to understanding that multiplication is an extension from fractions to rational numbers by requiring that operations continue to satisfy the properties of operations, particularly the distributive property, leading to products such as -1 times -1 equals 1, and the rules for multiplying signed numbers, and that's where we'll focus today. So by the end of the lesson, you'll be able to multiply integers. We won't quite talk about the distributive property yet, but we will also understand the rules for multiplying signed numbers. So the first slide, and you need to write this down, is multiplying two integers with different signs. So when you multiply two integers with different signs, the product is negative. So you can see in the two generalized examples here, a positive times a negative would give you a negative, and a negative times a positive also gives you a negative. So in the example down here, it's 2 times -6, or -2 times 6. They both give -12. So when you're multiplying integers with different signs, you take their product, and the answer is negative. So here are some examples if you'd like to pause the video and write these down and try them on your own. -3 times 12, so it's a negative times a positive, so we get -36. 4 times -7, that's -28. 7 times -8, that's -56. -6 times 12, hopefully you know your multiplication facts through 12 at least, and that is -72. Notice the different ways that we use multiplication symbols. We have the dot and also parentheses, so that all means multiplication. You won't see me use the X for multiplication. That's a habit you should try to get out of, since we start dealing so much with variables, and the multiplication symbol looks, that is the X, looks so much like the variable X. The next slide is about multiplying two integers with the same sign. So the product of two integers with the same signs is positive. So in the general example here, A times B, so positive A times positive B would be, your answer is positive AB. And if you have negative A times negative B, you would also get positive AB. And in the example down here, 4 times 6 is 24. And -4 times -6 is also 24. So some examples here. -5 times -7 is positive 35. 8 times 14. Remember, we're not using a calculator, and I'm not sure how many of you know your multiplication facts past the 12s, so off to the side you could do 14 times 8, and you would just do this longhand, so we get 32. 8 times 1 is 8 plus 3, 112, so positive 112. -5 times -11 is 55, positive 55. -13 times -4, again, if this isn't one you know, off to the side you could do some work. 13 times 4, and don't worry about the signs right now. We know that the sign rules don't matter as far as what the actual answer is, so we'll worry about -13 and -4 later. But 3 times 4 is 12, 4 times 1 is 4, plus 1 is 5, and again, a negative times a negative is a positive, so positive 52. Here we're still doing products of integers, but we've got more than one multiplication problem. Remember that multiplication goes from left to right. So for number 9, we're going to do -4 times 2 first, and that will give us -8. And we're going to multiply that by -5 to get positive 40. If you'd like to pause the video here and try number 10 on your own, and then you can check your answer. So negative 3 times negative 5 is positive 15. And we're going to do positive 15 times negative 6. And if you do this longhand, you'll get 90, but a positive times a negative should be negative 90. Over the last several days, we've done some evaluations, simplifying expressions when we're supposed to be substituting in numbers for the variables. So the expression is 3xy. And I'd like you to get in the habit of actually rewriting the problem with the substitutions. So next we would write 3 times 2 times negative 6 is x and y. So remember, when a variable or coefficient is all lined up here with no symbol, it's all multiplication. So 3 times 2 is 6, and then we bring down the negative 6. 3 times negative 6 is negative 36. In class, we'll work on worksheet 1-4. I do want to show you a little trick that I had a student teach me several years ago, and maybe some of you have seen this before, but if you're struggling to remember the signs for multiplication with integers, fractions, decimals, draw yourself a tic-tac-toe board and put the positive sign in the diagonal. Once you have the positive sign in the diagonal, you're going to write negative signs everywhere else. And if you look at these tic-tac-toe spots and think of it as a problem, you can always get the signage right for multiplying and dividing. So we'll do it with multiplication today, but if we start and it works horizontally across, it works vertically up and down, it works both directions, from the bottom up or from the top down. Diagonals work, both diagonals work. It works backwards from right to left, but this is how it works. So if we start in the upper left hand corner, you say a positive, and I'll use a highlighter here so maybe we can see it a little better, but we can say a positive times a negative is a negative. So that's how that one would work. If you go another way, let's go backwards down here. A positive times a negative is a negative. The same row, and we go the other direction, a negative times a negative is a positive. So jot this down in your notes. It's kind of a neat little reference. Occasionally I'll give a test or an assessment or even on homework, and I'll see students write this down. So if this is helpful for you, please use it. Again, the diagonal works too. Positive times positive is positive.